Welcome back to the A+ Tutor. Today we're going over how to solve quadratic equations by factoring, completing the square, and using the quadratic formula. First, let's go over how to solve quadratic equations by factoring. Say we have an equation x squared minus 9x plus 18 equals 0. Our quadratic equations are typically going to be in the form ax squared plus bx plus c equals 0, where a, b, and c are all the coefficients of our function. And this is what we're going to use to find our factors. So in this case, our a is equal to 1 because there's nothing in front of our x squared term. Our b is equal to negative 9. We always want to take that negative or minus sign if it's there. You never want to leave it off. So if you see a minus sign, that's going to be a part of your a, b, or c term. And then our c is 18. So our first step when we're solving by factoring is to first multiply our a and c terms, find the factors of a times c, and whichever factors of a times c that add to give you b are going to give you our factors. So we already found our a, b, and c earlier. So our a times c is going to be 1 times 18, which is equal to 18. The factors of 18 are 1 and 18, 2 and 9, and 3 and 6. So we want to figure out which one of these factors will add to give us our b term, which is negative 9. Now, when we think about our factors, we're going to use any combination of positive and negative factors. So it's going to just depend on whatever our b term is. So 1 and 18 gives us 1 plus 18 equals 19. Negative 1 plus 18 equals 17. 1 minus 18 is negative 17. And negative 1 minus 18 is negative 19. So we know these are not our factors because none of those add to give us negative 9. Then we have 2 and 9. So 2 plus 9 equals 11. Negative 2 plus 9 equals 7. 2 minus 9 equals negative 7. And negative 2 minus 9 is negative 11. None of those factors add to give us negative 9, so it's not 2 and 9. It must be 3 and 6, but what combination of positive and negative do we need? So let's take a look. 3 plus 6 is positive 9, but we need negative 9, so it's not that. Negative 3 plus 6 is 3. 3 minus 6 is negative 3. And negative 3 minus 6 is negative 9, which is exactly what we're looking for. So we know our factors are 3 and 6, and we know it's negative 3 and negative 6. So now we can move into step 2, which is rewriting our expression and expanding our b with our two new factors. This means our x squared minus 9x plus 18 becomes x squared. Our negative 9x becomes minus 3x minus 6x. Negative 3 minus 6 is equal to negative 9. Plus 18 equals 0. Next, we're going to factor by grouping. When we factor by grouping, we're going to factor each half of our function individually. So our new equation is x squared minus 3x minus 6x plus 18 equals 0. So we're going to split that in half. On our left side, we're going to factor out an x from x squared minus 3x, and we're left with x minus 3. On our right side, we're going to factor out a negative 6, and we're left with x minus 3 equals 0. So our new expression becomes, when we factor out our x minus 3 term, we can pull out x minus 3, and we're left with x minus 6 equals 0. And our last step is to set each binomial equal to 0 and solve for x. So we have x minus 3 times x minus 6 equals 0. So we're going to set each of these equal to 0. We'll have x minus 3 equals 0 and x minus 6 equals 0. This is due to our zero product property. So now we're going to solve for x in both of these. So on our left side, we have x minus 3 equals 0. We'll add 3 to both sides, and we'll get x equals 3. And on our right side, we have x minus 6 equals 0, so we'll add 6 to both sides, and we get x equals 6. And we've just solved our quadratic equation. So we solved and found that our x values are x equals 3 and x equals 6, and that's exactly what we were looking for. So now whenever we solve our quadratic equations by factoring, we're going to follow these 4 steps. We're going to multiply our a times c and find the factors of a and c that add to give us b. Then we'll rewrite and expand our expression with our 2 new factors. We'll factor by grouping, then set each of those binomials equal to 0 to solve for x. Let's take some examples. Our first example is 4x squared plus x minus 3 equals 0. Let's start by identifying our a, b, and c terms. Remember, our equations are in the form ax squared plus bx plus c equals 0. So here our a is equal to 4, our b is equal to 1 since there's nothing in front of our x, and our c is equal to negative 3. We have that minus 3, so we want to make sure we include that. So step 1, we want to multiply our a and c so that we can find our factors that add to b. So our a times c is going to be 4 times negative 3, which is negative 12. Our factors of negative 12 are going to be 1 and 12, 2 and 6, and 3 and 4. Now earlier when I was going over this, we did go through each one of these factors to try and find our solution. We're not going to do that this time. Let's take a look at our factors and see which are going to add to give us 1. 1 and 12 will not give us 1, 2 and 6 will not give us 1, but 3 and 4 will. So we know our factors are going to be 3 and 4, and we know in order to get positive 1, we need a negative 3. So negative 3 plus 4 equals 1, which is exactly what we're looking for. So now, step 2 is we're going to replace b with our factors. So our equation becomes 4x squared plus 4x minus 3x minus 3 equals 0. Now we can factor by grouping. So we're going to split this in half and factor each side by itself. So on the left side, we can factor out a 4x, and we're left with x plus 1 from each of our terms. On the right side, we can factor out a negative 3, and we're left with x plus 1 from each of our terms. Now, let's finish our factoring. So we can pull out our x plus 1 and just write that one time. And then we're left with 4x minus 3 in our other binomial. Now for our last step, we're going to set each of these equal to 0, and we're going to solve for our x. So we'll have x plus 1 equals 0, and 4x minus 3 equals 0. For our left binomial, we'll subtract 1 from both sides, and we get x equals negative 1. On our right binomial, we'll add 3 to both sides. We get 4x equals 3. Then divide both sides by 4, and we get x equals 3 over 4. So our two values for x are negative 1 and 3/4. Example 2, we have x squared equals 8x minus 15. So for all of these problems, we've been going based off of ax squared plus bx plus c equals 0. So we want our expression to look like that. Right now, we have x squared equals 8x minus 15. So we want all of our numbers on one side, the left side, and our 0 on the right side. So what we're going to do is we're going to subtract 8x and add 15 to both sides to move this over to our other side. So now our expression becomes x squared minus 8x plus 15 equals 0. And now we can identify our a, b, and c terms. So sometimes you are going to have to rearrange your expression so that it looks like ax squared plus bx plus c equals 0. So now, because we've done that, we know our a is equal to 1, our b is equal to negative 8, and our c is equal to 15. So let's take that first step. A times c is 1 times 15, which is 15. And our factors of 15 are 1 and 15, and 3 and 5. Now again, we don't need to go through all the sums and differences of 1 and 15 and 3 and 5. We know to get negative 8, we're going to need 3 and 5. And because we want negative 8, that means we need a negative 3 and a negative 5. Now, typically, as we've done for the past 2 examples, we would replace our b with our factors and we'll factor by grouping. But we can take a little bit of a shortcut here. Once we find our factors, we can jump right to our two binomials by just plugging those in. Whenever our a term is 1, we can just write two factors. This is going to be x plus or minus something, x plus or minus something equals 0. And whatever goes in here, those are our two factors. So x minus 3, x minus 5 equals 0. And I'll prove it to you by factoring by grouping. So we know in our second step, we're going to replace b with our factors. So this would become x squared minus 3x minus 5x plus 15 equals 0. When we split that in half, we would factor out an x and be left with x minus 3. We would factor out a negative 5 and be left with x minus 3 equals 0. And when we factor out our x minus 3, we're left with x minus 5 equals 0, which is exactly the same as what we saw right here. So instead of having to go through steps 2 and 3 and factor by grouping and take all of those extra steps, we can jump right to our factors by saying x plus our first factor and x plus our second factor. So because our a is equal to 1, we're able to do this. When our a is greater than 1, there's one extra step we have to take, but we can do something really similar. So instead of taking steps 2 and 3, we're just going to find binomials. And now we can use our zero product property to solve for our x values. We get x minus 3 equals 0 and x minus 5 equals 0. On our left side, we're going to add 3 to both sides. So we get x equals 3. On our right side, we're going to add 5 to both sides. So we get x equals 5. And our two answers are 3 and 5. Here's our third example. 4x squared equals 12x minus 9. Again, we want to make sure all of our terms are on one side and our zeros on the other side. So we're going to subtract 12x from both sides and add 9. So we get 4x squared minus 12x plus 9 equals 0. And now this is in our ax squared plus bx plus c equals 0 format. This means our a is 4. Our b is negative 12, and our c is 9. So our first step is our a times c, which is 4 times 9, which is going to be equal to 36. Our factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So we need to find the factors that add to give us negative 12. Out of all of these factors, 1 and 36 will not give us 12, 2 and 18 will not give us 12, 3 and 12 will not give us 12, 4 and 9 will give us 12, but 6 and 6 will. And in order to get 12, we need negative 6 plus negative 6. Now, I mentioned in our previous problem, we can jump straight to our factors. But if we jump straight to our factors using negative 6 and negative 6 the way we just did, and we do 4x minus 6 times 4x minus 6 equals 0, if we were to multiply that back out, we're not going to have our original expression, which is 4x squared minus 12x plus 9 equals 0. If we FOIL this and multiply this out, we're going to have 36x squared minus 48x plus 36 equals 0, which is not what we're looking for. So we cannot do this at all. Instead, whenever our a term is greater than 0, we basically want to come up with two fractions and simplify those, and that's going to give us our two binomials. So what we do is we take our a, 4x, and we put it over one of our factors, and then we take our a and put it over our other factor so that we can simplify this. So this is going to become our binomial. 4x over 6, when we simplify that, we get 2 over negative 3, and 4x over 6, we get 2 over negative 3 again. So our binomials are actually going to be 2x minus 3 times 2x minus 3 equals 0. And if we FOIL that out, we should get our 4x squared minus 12x plus 9 equals 0. So first, outside, inside, last, if we remember our FOIL method, 4x squared minus 6x plus 9, which is 4x squared minus 12x plus 9. That is exactly what we had before. So whenever our a is greater than 1, we want to just take two fractions with our terms that we found and simplify them. Now we can split this and solve for our x values. So we have 2x minus 3 equals 0 and 2x minus 3 equals 0. As we can see, we're going to have the same value twice, so I don't need to do this twice. I'll solve one of them. We'll add 3 to both sides, and we get 2x equals 3. Divide both sides by 2. And x is equal to 3 halves. And that's our answer. We have one value for x, and it is 3 over 2. So whenever our a is greater than 1, we just want to take two fractions, simplify those, and we'll find our binomials. All right, here's our fourth example. X squared minus 4x minus 12 equals 0. So our a is equal to 1, b is negative 4, and c is negative 12. Step 1, a times c, which is 1 times negative 12, and that gives us negative 12. Our factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So our factors that are going to add to give us negative 4 are going to be 2 and 6. And since we need a negative 4, we know that's going to be a positive 2 and a negative 6. So 2 minus 6 gives us negative 4. So now we can find our binomials. We'll plug those two values in. So we'll have x plus 2 times x minus 6 equals 0. We can split that up into our two equations and solve for x. So x plus 2 equals 0 and x minus 6 equals 0. On our left side, we'll subtract 2 from both sides and get x equals negative 2. On our right side, we'll add 6 to both sides and we get x equals 6. So our answers here are negative 2 and 6. For our next example, example 5, we have 6x squared plus 21x minus 27 equals 0. So whenever we have an expression like this where we've got kind of these large numbers, but we look at our a, b, and c terms and see that there is a common factor between them, the first step we always want to take when we are solving these expressions is divide by that greatest common factor. So this is kind of an extra first step we need to take, or a pre-step in some cases that we need to take to make sure that we can find our factors really easily and really simply. We also don't want to have to work with 6 times 27 if we don't have to. If we were to do that, we're going to have a long list of possible factors for our binomials, and it's going to take us so much more time to solve this. So let's make this problem a bit easier by dividing everything by our greatest common factor. In this case, our greatest common factor is 3. So we're going to divide everything on the left and everything on the right by 3. So 6x squared gets divided by 3. 21x gets divided by 3, negative 27 gets divided by 3, and 0 gets divided by 3. So now this leaves us with 2x squared plus 7x minus 9 equals 0. Now remember, I can do 0 divided by 3. I cannot do 3 divided by 0. This is just a fraction. 0 out of 3 is always going to be 0. But 3 pieces out of 0 is undefined. So I can do 0 divided by 3. I just get 0. And we see my new expression. So now I take my steps like normal. A equals 2, B equals 7, and C is negative 9. A times C is going to be 2 times negative 9, which is negative 18. Our factors of negative 18 are going to be 1 and 18, 2 and 9, and 3 and 6. Now the factors that add to give us positive 7 are going to be 2 and 9, with a negative 2 and a positive 9. Now we'll take our fractions. So we're not going to jump right into 2x minus 2 and 2x plus 9 because that's not going to be correct. We're going to first take our fractions, 2x over negative 2 and 2x over positive 9. So on our left side, we're going to be left with 1x minus 1. And our right fraction does not simplify. So our binomials are going to be x minus 1 times 2x plus 9 equals 0. Now we can solve for our x's. So x minus 1 equals 0, and 2x plus 9 equals 0. On the left side, we'll add 1 to both sides, and we'll get x equals 1. On the right side, we'll subtract 9 from both sides. So we get 2x equals negative 9. Divide both sides by 2. And we're left with x equals negative 9 over 2. And those are our values for this expression, x equals 1 and x equals negative 9 over 2. And here is example 6, our last example for solving by factoring. We have x squared plus 4x minus 32 equals 0. Our a is 1, b is 4, and c is negative 32. So our a times c is going to be 1 times negative 32, which is negative 32. The factors of 32 are 1 and 32, 2 and 16, and 4 and 8. The factors of 32 that are going to add to give us positive 4 are going to be 4 and 8, and since we need a positive 4, we're going to have a negative 4 and a positive 8. Our a term is 1, so we can just find our factors. So we know these factors are going to be x minus 4 times x plus 8 equals 0. We can separate these and solve for each one of our binomials. X minus 4 equals 0 and x plus 8 equals 0. On our left side, we'll add 4 to both sides. So we get x equals 4. On our right side, we'll subtract 8 from both sides, and we get x equals negative 8. And those are our answers. Next, let's go over how to solve quadratic equations by completing the square. When we solve by completing the square, we're creating a perfect square trinomial so that we can solve our quadratic function. Let's take a look at an example of this. Say we have x squared minus 12x plus 23 equals 0. Remember, our quadratics are in the form ax squared plus bx plus c equals 0. So we still want to know what our a, b, and c terms are. In this case, our a is 1, our b is negative 12, and our c is 23. Our first step is going to be dividing, if needed, by a. Our leading coefficient should always be 1 whenever we are completing the square, so we may need to divide all of our terms by our a term if a is not equal to 1. In this case, our a term is 1, so we don't have to do anything. Our next step is to add our b over 2 squared to both sides. So let's find our b over 2 squared. Since b is equal to negative 12, then b over 2 squared is going to be negative 12 over 2 squared, which is equal to negative 6 squared, which is 36. So we're going to take 36 and add this to both sides of our equation. So we have x squared minus 12x. Whenever we're doing this, we want to connect this to our b. So we're going to add it right here after our bx term. So we're going to do plus 36 plus 23 equals 0 plus 36. The reason why we're able to add it to both sides is because if I were then to subtract it to both sides, it's the same value. So whatever you do to one side, you must do to the other side, or else you're changing the value of your expression. So when I add my b over 2 squared to the left side, I have to add it to the right side, and the value of my expression stays exactly the same. Our next step is to factor our perfect square trinomial. By taking our b term, dividing it by 2 and squaring it, and then adding it to both sides, we are creating a perfect square trinomial with these terms. So now we're able to factor this so that we can solve for x. And remember, we can really easily factor our perfect square trinomials just by memorizing what those are. So a perfect square trinomial has the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So when we have two plus signs, this becomes a plus b squared. And when we have a plus and a minus sign, we have a minus b squared. In this case, our a is x and our b is 6. So x squared minus 12x plus 36 becomes x minus 6 squared. And then we can write the rest of our expression. Plus 23 equals 36. This is now going to help us solve for x, which is our last step. So now to solve for x, we'll start by subtracting 23 from both sides. And we get x minus 6 squared equals 13. Then we're going to take the square root of both sides to get rid of our square. Whenever we take the square root, we have to consider the positive and the negative value of our square root. So x minus 6 equals plus or minus the square root of 13. Let's add 6 to both sides. And we get x equals 6 plus or minus the square root of 13. So when we are solving by completing the square, we first want to divide everything by our a term if it's not 1. Add b over 2 squared to both sides. Factor the perfect square trinomial. And then solve for x. Now let's look at some examples of solving our quadratics by completing the square. For our first example, we have x squared plus 4x minus 7 equals 0. So let's identify our a and b terms. When we were solving quadratics by factoring, we needed a, b, and c. But for completing the square, we only need our a and b. So in this case, our a is 1 and our b is 4. If a were greater than 1, we'd have to divide everything by our a term, but since it's not, we can skip the first step. Next, let's figure out what our b over 2 is. So b over 2 is going to be 4 over 2, which is equal to 2. Now we know we can plug that in and add b over 2 squared to both sides. So our expression becomes x squared plus 4x plus 2 squared minus 7 equals 0 plus 2 squared. We want to add it to both sides. In other words, we have x squared plus 4x plus 4 minus 7 equals 4. Now x squared plus 4x plus 4 is our perfect square trinomial. And this one is in the form a squared plus 2ab plus b squared, which means when we factor it, we're going to get a plus b squared. So that's why finding our b over 2 term is helpful, because I know my a is x and my b is 2. So this becomes x plus 2 squared minus 7 equals 4. Now we can solve for our x. We'll start by adding 7 to both sides, and we get x plus 2 squared equals 11. Take the square root on both sides. X plus 2 will be equal to the positive and negative square root of 11. Subtract 2 from both sides, and we're left with x equals negative 2 plus or minus the square root of 11, which is our answer. Here's our second example. 4x squared minus 8x plus 1 equals 0. So now we have an a that is greater than 1. So first let's identify our a and b terms. Our a is 4 and our b is negative 8. Since a is greater than 1, we need to divide all of our terms by a. So everything gets divided by a. This means our expression is x squared minus 2x plus 1 over 4 equals 0. So now our b is no longer negative 8, our b is equal to negative 2. And we're able to now complete the square. B over 2 is going to be negative 2 over 2, which is equal to negative 1. This means our expression becomes, when we add b over 2 squared to both sides, x squared minus 2x plus negative 1 squared plus 1 over 4 equals 0 plus negative 1 squared, which is equal to x squared minus 2x plus 1 plus 1/4 equals 1. Now again, we have our perfect square trinomial, this time in the form a squared minus 2ab plus b squared, which means when we factor this, we're going to get a minus b squared. Our a is x and our b is negative 1. So when we factor this, we get x minus 1 squared plus 1/4 equals 1. Now, let's solve for x. Subtract 1/4 from both sides. We get x minus 1 squared equals 3/4. So if we do this math, we have 4 over 4 minus 1 over 4, which is 3 over 4. Next, we'll take the square root of both sides. So we're left with x minus 1 equals the positive and negative square root of 3 over 2. The square root of 4 is 2, so we can simplify our denominator. And last, we'll add 1 to both sides. So we get our answer. X is equal to 1 plus or minus the square root of 3 over 2. Example 3. We have x squared minus 8x minus 12 equals 0. Our a is 1 and our b is negative 8. Since our a is 1, we don't have to divide by anything, and we can find our b over 2. So b over 2 is negative 8 over 2, which is equal to negative 4. Now let's add b over 2 squared to both sides. So we get x squared minus 8x plus negative 4 squared minus 12 equals 0 plus negative 4 squared. So this becomes x squared minus 8x plus 16 minus 12 equals 16. This is our perfect square trinomial in the form a squared minus 2ab plus b squared, which means we're going to factor this into a minus b squared. A is x, b is 4. So this becomes x minus 4 squared minus 12 equals 16. And now we can solve for x. So we'll add 12 to both sides, and we get x minus 4 squared equals 28. Take the square root of both sides. On the left side, we're left with x minus 4, and on the right side, our square root of 28 can be simplified. 28 is equal to 4 times 7. The square root of 4 is 2, and the square root of 7 cannot be simplified. So we can rewrite this as the positive and negative 2 times the square root of 7. Add 4 to both sides, and our x is equal to 4 plus or minus 2 times the square root of 7. And for our fourth example, we have x squared plus 10x minus 57 equals 4. We'll take the same steps. Our a is equal to 1 and our b is equal to 10. So b over 2 is going to be equal to 10 over 2, which is 5. This means when we add our b over 2 squared to both sides, we get x squared plus 10x plus 5 squared minus 57 equals 4 plus 5 squared. So this becomes x squared plus 10x plus 25 minus 57 equals 4 plus 25. This is our perfect square trinomial, a squared plus 2ab plus b squared, which factors into the form a plus b squared. So this becomes x plus 5 squared minus 57 equals 29. Now we can solve for our x. So we'll add 57 to both sides. This gives us x plus 5 squared equals 86. We'll take the square root of both sides. The square root of 86 can't be simplified since 86 is 2 times 43, and 43 is a prime number. So we're just left with the positive and negative square root of 86. Next, we'll subtract 5 from both sides, and x is equal to negative 5 plus or minus the square root of 86. All right, we've got two more examples. So here's example 5. 5x squared plus 8x minus 40 equals 8. Our a is equal to 5, which means we're going to have to divide everything by 5. So our new expression becomes x squared plus 8 over 5x minus 8 equals 8 over 5. Now, our a is equal to 1, and our b is equal to 8 over 5. b over 2 is going to be equal to 8 over 5 over 2, which is 4 over 5. Now we'll add 4 over 5 squared to both sides of our equation. So this becomes x squared plus 8 over 5x plus 4 over 5 squared minus 8 equals 8 over 5 plus 4 over 5 squared. So this is x squared plus 8 over 5x plus 16 over 25 minus 8 equals 8 over 5 plus 16 over 25. We have our perfect square trinomial in the form a squared plus 2ab plus b squared, which factors into a plus b squared. So when we factor this, we get x plus 4 over 5 squared minus 8 equals, when we add our right side of our equation together, our 8 over 5 can be rewritten as 40 over 25. So then our fraction will be 56 over 25. And now we can just solve for x. So we'll start by adding 8 to both sides. When I add 8 to my right side, I do need to convert this into a fraction. So we're going to multiply top and bottom by 25. So this becomes 56 over 25 plus 200 over 25, which is equal to 256 over 25 for the right side of our equation. So we get x plus 4 over 5 squared equals 256 over 25. We'll continue to solve this like normal. Although we have a fraction, our steps don't change. We just might have to do a little bit of extra work because we have a fraction. So we'll take the square root of both sides. On our left side, we're left with x plus 4 over 5. And on our right side, we have positive and negative. The square root of 256 is 16 over the square root of 25 is 5. So we are able to simplify that. We'll subtract 4/5 from both sides. Now here, this means we get x equals negative 4 over 5 plus or minus 16 over 5. So we actually can simplify these since we don't have our square root. We can break this up into two expressions. So we get x equals negative 4 over 5 plus 16 over 5. And x equals negative 4 over 5 minus 16 over 5. So that means for on our left side, negative 4 over 5 plus 16 over 5 gives us 12 over 5. And on our right side, negative 4 over 5 minus 16 over 5 is negative 20 over 5. Or we can simplify that to negative 4. And those are our two values for x. Although we're working with fractions, we still just follow our same steps to get our same results. And this time we did end up with two values for our x rather than having an expression with the square root. And here's our last example for this section. 6x squared minus 12x minus 14 equals 4. Our a is 6, which means we're going to have to divide everything by 6. So that gives us x squared minus 2x minus 14 over 6 can be simplified to 7 over 3. So minus 7/3 equals, and 4 over 6 can be simplified to 2 over 3. Now, our a is 1 and our b is negative 2. So this means b over 2 is equal to negative 2 over 2, which is negative 1. So let's add b over 2 squared to both sides. We get x squared minus 2x plus negative 1 squared minus 7 over 3 equals 2 over 3 plus negative 1 squared, which is x squared minus 2x plus 1 minus 7/3 equals 2/3 plus 1. Our perfect square trinomial is in the form a squared minus 2ab plus b squared, which means when we factor it, we're going to get a minus b squared. So this becomes x minus 1 squared minus 7/3 equals, 1 is the same as 3 over 3, so this is going to be equal to 2/3 plus 3/3, which is 5/3. Now let's solve for x. We'll add 7/3 to both sides. We get x minus 1 squared equals 12 over 3, which actually is 4. Then we can take the square root on both sides. So we get x minus 1 equals the positive and negative square root of 4, or 2. And then we can add 1 to both sides. So x is equal to 1 plus or minus 2. But we can solve this. So we have two expressions, x equals 1 plus 2 and x equals 1 minus 2, which means x is equal to 3 and x is equal to negative 1. And those are our values for x. So we've learned how to solve quadratic equations by factoring and by completing the square. So now we're going to solve our quadratic equations using the quadratic formula. So our quadratic equation is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is one of those formulas that you just memorize. By memorizing it, you're able to use it and solve your expressions using the quadratic formula. So say we have the quadratic equation 2x squared minus 14x plus 23 equals 0. So our first step when we are using the quadratic formula to solve our equations is going to be to identify our a, b, and c terms. So remember, our standard form of our equations are ax squared plus bx plus c. In this case, our a is equal to 2, our b is equal to negative 14, and our c is equal to 23. So step 2 is just to plug it in and solve. So with our a, b, and c, we'll get x equals negative, our b term, which is negative 14, plus or minus the square root of b squared, negative 14 squared, minus 4 times a, which is 2, times c, which is 23, all over 2 times a, which is 2. And then we just simplify and solve this. So this is 14 plus or minus the square root of 196 minus 4 times 2 is 8, and 8 times 23 is 184, all over 4, which is equal to 14 plus or minus the square root of 12, 196 minus 184 is 12, all over 4. The square root of 12 can be simplified because we have the square root of 12 is equal to the square root of 3 times 4, and 4, the square root of 4 is 2, so we're left with 2 square root of 3. That means x is equal to 14 plus or minus 2 times the square root of 3 over 4. In this case, we can simplify, so we can factor out a 2 in our numerator and factor out a 2 in our denominator. So if we take 2 out of everything, we're left with x is equal to 7 plus or minus the square root of 3 over 2. And that would be our answer. So by using the quadratic formula, we're able to find exactly what our x values are and simplify this as far as we can. In this case, we can't simplify this any further. Sometimes we can, but we would just find the simplest form of this expression, and those are the values for our x. Let's look at some examples. For our first example, we have x squared minus 3x minus 3 equals 0. So first, let's identify our a, b, and c. Our a is 1, b is negative 3, and their c is also negative 3. Now, whenever we're using any type of formula, especially one that you want to memorize, it's best that you write it down every single time because that's going to help you memorize and remember this formula. So our formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So that means our x is equal to the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 3 all over 2 times 1. So this is equal to 3 plus or minus the square root of 9 plus 12 all over 2, which means x is equal to 3 plus or minus the square root of 21 over 2. Since the square root of 21 cannot be simplified, we are done, and this is our answer. Example number 2. 4x squared plus 8x minus 1 equals 0. So our a is 4, our b is 8, and our c is negative 1. Again, our formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to the opposite of 8 plus or minus the square root 8 squared minus 4 times negative 1 all over 2 times 4. So this is equal to negative 8 plus or minus the square root of 64 plus 16 all over 8, which is equal to negative 8 plus or minus the square root of 80 over 8. The square root of 80 can be simplified because the square root of 80 is equal to the square root of 16 times 5, and the square root of 16 is 4, so we'll just leave that square root of 5. So this becomes negative 8 plus or minus 4 square root 5 all over 8. And this can all be simplified. Every single term can be divided by 4. So if we factor out a 4 from everything, we're left with 2, 1, and 2. So our x is equal to negative 2 plus or minus the square root of 5 over 2. And that's our answer. For our next example, we have 4x squared plus 7x minus 15 equals 0. Our a is 4, our b is 7, and our c is negative 15. Our formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So plugging everything in, we get x equals the opposite of 7 plus or minus the square root of 7 squared minus 4 times negative 15 all over 2 times 4. So this is equal to negative 7 plus or minus the square root of 49 plus 240 all over 8, which is equal to negative 7 plus or minus the square root of 289 all over 8. The square root of 289 can be simplified because 289 is 17 times 17, so that's equal to 17. So our x is equal to negative 7 plus or minus 17 over 8, which means we can find our two values for x. So we have x equals negative 7 plus 17 over 8, and x equals negative 7 minus 17 over 8. So on the top side, we have 10 over 8, and simplifying that, both are divisible by 2. So we get 5 over 4, and x is equal to 5/4. On the bottom, we get negative 24 over 8, which simplifies, and we get x equals negative 3. So our two answers are positive 5/4 and negative 3. And now for our fourth example, x squared minus 2x minus 48 equals 0. Our a is 1, b is negative 2, and c is negative 48. Again, let's write out our quadratic formula. So x equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. Plugging that in, we get x equals the opposite of negative 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 48, all over 2 times 1. So this is equal to 2 plus or minus the square root of 4 plus 192 all over 2, which is 2 plus or minus the square root of 196 over 2. The square root of 196 does simplify and is equal to 14. So this means we have x equals 2 plus or minus 14 over 2. So we can split this up and find our values for x. X equals 2 plus 14 all over 2, and x equals 2 minus 14 all over 2. On the top, this gives us 16 over 2, or x equals 8. And on the bottom, this gives us negative 12 over 2, or x equals negative 6. So our two values for x are 8 and negative 6. Example number 5. We have x squared minus x minus 3 equals 0. Our a is 1, our b is negative 1, and our c is negative 3. Again, let's write out our quadratic. X equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2 times a. So x equals the opposite of negative 1, plus or minus the square root of negative 1 squared minus 4 times 1 times negative 3, all over 2 times 1. So this is equal to 1 plus or minus the square root of 1 plus 12 all over 2, which means x is equal to 1 plus or minus the square root of 13 over 2. This can't be simplified any further, so that's our answer. And for our last example, we have 2x squared plus 18x plus 39 equals 0. Our a is 2, our b is 18, and our c is 39. Again, our quadratic formula is x equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2 times a. So this means x is equal to the opposite of 18, plus or minus the square root of 18 squared minus 4 times 2 times 39, all over 2 times 2. So this is equal to negative 18 plus or minus the square root of 324 minus 312 all over 4. So this is equal to negative 18 plus or minus the square root of 12 over 4. The square root of 12 can be rewritten as 2 times the square root of 3 because the square root of 12 is equal to the square root of 3 times 4, or 2 times the square root of 3 when you pull out that 4. So this means we get negative 18 plus or minus 2 square root 3 over 4. And we can simplify this because all of these are a factor of 2, so we can factor out a 2 from everything. We'll have negative 9, 1, and 2, which means x is equal to negative 9 plus or minus the square root of 3 over 2. And that's our final answer. Thank you so much for watching. I hope you enjoyed. If there are any topics you'd like for me to cover, leave them in the comments down below. Make sure you're subscribed to my channel so you never miss a video. See you next time.